Hello and welcome to this edition of Live and Ticking, which will focus on the topic of clinical trials. I'm Fearghal McKinney, Head of British Heart Foundation Northern Ireland. So today we're talking about clinical trials. Clinical trials are research studies involving human volunteers that tests a healthcare intervention, such as a drug or diagnostic test, to help answer an unresolved clinical question. For example, will this new treatment work better than the existing treatment? Is there a better way to identify people at risk of a future heart attack? This drug helps people with heart failure. Could it also help people with kidney disease? Modern healthcare is dependent on decisions. For example, should this drug or that drug be used to help this patient's symptoms? These decisions need to be based on evidence, and the best possible evidence we can get comes from clinical trials. The first known clinical trial to take place was on board a ship in 1747, when naval surgeon James Lind tested different treatments for scurvy. He selected 12 sailors with scurvy who all had similar symptoms and were all on the same diet, and split them into groups of 2 people who all received different additions to their diet, such as cider, vinegar, or nutmeg. But only those who were given 2 oranges and 1 lemon each day got better, proving that citrus fruit could help improve the symptoms of scurvy. Remarkably, more than 2.5 centuries later, Lind's tiny study remains the prototype for the large, sophisticated clinical trials researchers perform today. Randomized clinical trials have become the gold standard way of testing whether a new tablet, surgical technique, or any other type of healthcare intervention is safe and beneficial for the people receiving it. They involve recruiting the right people to help answer the question. For example, living with heart failure, who are randomly assigned to different treatment groups to help minimize any hidden source of bias. For example, those in the treatment group might receive a new drug, and those in the control group might receive the current standard treatment. Sometimes the control group might receive an inactive treatment, like a placebo pill that doesn't contain any drug, to help prove that any effect is truly down to the treatment. The groups will then be followed up by the researchers for a set period of time, for example, to track their symptoms in the year after they join the study. Comparing the 2 groups enables us to compare how safe and effective the treatment options are. So, if fewer people in one group needed to be hospitalized due to their heart failure over the follow-up period, you might be able to conclude that that treatment is better for patients. Over our 60-year history, BHF-funded clinical trials have helped to make substantial advances in cardiovascular care. For example, in the late 1980s, the ISIS-2 trial showed that aspirin and clot-busting drugs can help save the lives of heart attack patients, transforming treatments for people who've had a heart attack. In the early noughties, another study, part-funded by BHF, the Heart Protection Study, proved the benefits of statins for people at high risk of coronary heart disease. More recently, the BHF has supported studies investigating how treatment of high blood pressure can be improved, whether it's safe to restart antiplatelet drugs like aspirin after a brain hemorrhage, and whether iron supplementation can benefit people with heart failure. The trial Professor Paul Kalra will be talking about today. We continue to fund clinical studies across a broad range of heart and circulatory conditions and their risk factors, and currently support 43 clinical trials across the UK, worth around £40 million. You can read more about the results of previous BHF-funded trials and which trials are currently taking place on our website. Our speakers today for this event will be discussing more about the clinical trial Ironman. First, we'll be joined by our guest researcher, Professor Paul Kalra. Paul will discuss his team's work on a 4-year-long clinical trial into patients with chronic heart failure to determine if treatment with intravenous iron is safe, if it cuts hospitalisation and reduces death. We'll then be joined by our guest case study, Steve Reid. Steve was a patient in the Ironman clinical trial and will be speaking about his experience with Ruth from our Heart Stories team. Now, before we move on to our speakers, I'd like to ask you our traditional quick poll question. And how would you rate your understanding of clinical trials? 1, of course, is very little. 5 is a lot. I'll just give you a little moment to answer that poll question. So we'd like to encourage you to post questions in the question and answer box throughout the event. And our speakers will answer as many as possible at the end of all the talks. Remember, you can put thumbs up to the questions you like most, as we'll ask the most popular questions first. We're also coming to the end of 2022 and are starting to think about topics for next year's live and ticking events. If you have a topic in mind that you'd be particularly interested in learning about, please put your suggestions in the comments box. Now, please let me introduce Professor Paul Kalra. Paul, as I say, has led up the Ironman trials, and welcome here, Paul.
Thank you very much. Pleasure to join you. Good late afternoon, stroke early evening to everyone. So I think probably useful to just give a bit of background to myself. I'm a cardiologist. I work in Portsmouth. I'm a clinician, but I'm also involved in research. And I specialize in heart failure within cardiology. So you may be aware that we, as doctors in cardiology, specialize and look after people with all aspects of heart problems. We then have niche specialties that might be treating coronary arteries, putting stents in, treating heart muscle problems like heart failure and devices, electrical problems. And I've been interested in heart failure for many reasons, but it's the fascination of how we've been able to develop treatments over the last 35 years that can really make a difference to patients that has been really important there. Firstly, trying to help patients feel better, and also, in addition, trying to improve what we call prognosis, what Fearghal's already alluded to, that is reduce the risk of needing to be hospitalized and hopefully prolonging life. And so I was going to talk a bit about how I got into Ironman research, that is, as opposed to exercise. And I'm very happy to take questions at the end. And I've got a few slides to go alongside this, and I hope you can see them. So Ironman, when you've got a title for your trial, it's usually a long title. So here, intravenous iron treatment in patients with heart failure and iron deficiency. And then you have the shorter, hopefully quite catchy acronym, and we liked Ironman, and that's what we went for. We presented this in the United States about 3 weeks ago at a big meeting called the American Heart Association, and published it online at the same time in The Lancet, which is one of our most prestigious medical journals in the world. What's interesting is we first came up with a concept for Ironman back in late 2013. So it takes a while to get these trials up and running and see them through to completion. And once we'd designed the trial and put an application in, we came to the British Heart Foundation, and it went through a rigorous review process. We had 9 reviewers look at this, and you get 9 to 18 pages of feedback and have to answer questions, adapt the trial accordingly. And we had around about a week to turn that around before it was reassessed. And then I'm pleased to say we were successful in obtaining the funding from the British Heart Foundation. So that is the background. So why Ironman and what's it about? Well, people with heart failure, and that's a condition where the heart muscle in the left ventricle doesn't contract as strongly as it should do. And that could be for many reasons, typically down to underlying coronary artery problems like heart attacks, high blood pressure, diabetes. For some people, it can run in families, but are many different causes of that. But what you find is when the heart muscle doesn't work as well as it should do, patients have symptoms such as shortness of breath, exercise limitation. Fatigue is one we often don't ask patients about, but it's a common disabling symptom. And there is high risk of heart failure hospitalisation, and for many, shortened life expectancy. We know that it's very common to have relative iron deficiency if your heart doesn't work well. And this is because the body doesn't seem to be able to utilize iron, so it can't absorb it as well from the gut, what we're taking in our diet, and can't utilize it and get it to where it needs to go in the body. So many people will appreciate that iron's needed for hemoglobin to stop you becoming anemic, but it's actually also very important for all cells to function. And prior to Ironman, we'd had a couple of relatively small and short-term studies that had been conducted in blinded fashion, so where the patients and the researchers didn't know what their patients were receiving. Intravenous iron, which is a dark brown liquid, versus placebo. And it had shown that certainly that in correction of iron deficiency could make people feel better and improve their exercise capacity. So something that patients would typically like to happen. But we weren't certain of the long-term safety and whether it impacted hospitalizations and reduced cardiovascular death. And that is what Ironman was designed to answer. So I've underlined a few things on this slide. So it's an investigator-initiated study. So this is a group of cardiologists involved in research, designed this, and as noted, was funded by the British Heart Foundation. We consented the vast majority of patients to permit their data, for us to link to their electronic health records, which meant we could, even if patients were unable to come up to see us in the research visits, we could track what happened to them. Were they admitted to hospital, etc. And that turned out to be really, really important because our trial runs through the COVID pandemic, and there were significant periods of time from March 2020, when we had the first lockdown, it's 2.5 years ago, that patients couldn't come to be seen in clinics. And so we were able to track still what happened to them. It was an iron called ferric diisomortose, and it's called a probe design. So it's randomized, like Fearghal said. So it's a flip of a coin by a computer as to whether you get randomized to intravenous iron plus best possible care versus best possible care alone. It's open label, and it's very difficult to blind intravenous iron. So you've got a dark liquid and clear saline going into the arm. You ask patients to put their arm through a little curtain and say, don't look at that. And some people will be tempted to have a little peek. It's a bit like Christmas in the Kalra household when I tell my 3 boys, don't go to the spare bedroom cupboard. You turn your back, bang, they're up there. But also you need a blinded and an unblinded research team, and it's really difficult to conduct. But what we had, because it was open label, was blinded endpoint adjudication. So the people who were looking at what happened to patients didn't know what the patient had received. I'm not going to go through this in great detail. It's just to inform you that there is structure to this, that not everyone with heart failure could get into a trial like this. And whatever condition you may have or be interested in, there'll be certain inclusion criteria that are trying to make the data as generalizable to the people with a condition. But actually, we also need to have people who are at slightly higher risk of a problem happening, because it's only by having higher risk individuals in the trial can we demonstrate with reasonable numbers of patients, it's often thousands of patients, that something's beneficial or not. If the patients are all very low risk, you might need 20 or 40,000 people in a trial, and that becomes very unwieldy and very, very expensive to conduct. And so this included people with contractile dysfunction and ejection fraction less than or equal to 45%. If we were designing the trial in 2020, undoubtedly 2022, we'd have slightly different criteria, because things have moved on since we designed this. And this is how we designed it 1-to-1. So half the patients get the intravenous iron, half get standard of care, and we're looking at heart failure, hospitalisation, and cardiovascular death. And we saw people at 4 weeks, 4 months, and then 4 monthly. and if they were in the intravenous iron arm, they would get more iron if they were iron deficient, only if they were iron deficient. And as I alluded to, COVID impacted lots of trials, but certainly trials like Ironman. If you're on a tablet trial and it was locked down, or hospitals weren't able to see people for research, or patients didn't want to come up to a hospital, and that would be very reasonable at the peaks of the pandemic. With a tablet trial, you can post the tablets to patients. For intravenous iron, you can't do that. You have to come up to hospital to be assessed and have intravenous iron. So we think there were long periods of time where people who may have become iron deficient again weren't receiving appropriate iron treatment. So we did this so-called sensitivity analysis, and that's what our regulatory bodies want us to do. This is some of the baseline characteristics. So we had 1,137 patients randomized across 70 United Kingdom centres. I'm just highlighting a few things. So the average age was 73 to 74. Now, the average age of people presenting with heart failure in the United Kingdom's about 78, 79. So it's a little bit younger than that. But actually, most trials to date, it's more typically mid-60s. So this is a more representative trial of people we're seeing in clinical practice. You look at this and you think, well, there's 3/4 of the patients are men. Does that mean heart failure only, primarily affects men? The answer to that is no. As we get older, it becomes a more equitable split. But this is very typical. Women are underrepresented in cardiovascular research, and that's something that, as a group of researchers in the UK, we would like to change and ensure that research is open to all patients, irrespective of whether they're man or woman, and irrespective of ethnicity as well. There's often a lack of ethnic diversity in research. And we found, I think as expected from COVID, as the trial progressed, fewer people attended in follow-up. And what we also found was, of those who were assigned to usual care without intravenous iron, actually a number of people outside of the trial did get intravenous iron, so 1 in 6 patients. And that's partly by the fact that other data have come out since we started Ironman to show, certainly if you're hospitalized with heart failure and you're iron deficient, that given intravenous iron could reduce the risk of hospitalization out to the next year. So we found that in the group that we were treating with intravenous iron, there were a proportion of people we didn't see, so I think undertreated. And yet in the group that we didn't want to get intravenous iron, this creep came in and 1 in 6 people got intravenous iron, lightly diluting the effects of the results. And this is what we found. This is called a Lynn-Ghost curve. You don't need to go away and remember that. And what we're looking at is, in the blue arm, this is what happens to people in usual care. In the red graph is what happens to people with intravenous iron. And what you see is the rate of heart failure hospitalizations and cardiovascular deaths, if you're on usual care, is 27.5 per 100 patient years. If you're on intravenous iron, that is about 5 absolute points different. That's quite a sizable difference in that sort of green box. The rate ratio is 0.82. What that means is there's an 18% reduction in the risk of heart failure hospitalization and cardiovascular death. But when we look at the p-value, this is what's the likelihood of this happening by chance. We want to see the p-value of less than 0.05. And that is a typical statistical way of saying this is unlikely to have happened by chance, because, of course, flipping coins, doing things can happen by chance. So this was just the wrong side of 0.05. But the other data we've got around intravenous iron, there's a study that I alluded to that had come out. It was almost identical rate ratio and very similar p-value. And the chances of this both happening by chance, is sort of less than 1 in 200. So we think this is likely to represent a genuine beneficial impact. And fewer patients had heart failure hospitalizations, fewer patients had cardiovascular death. and people felt better at 4 months when they were on intravenous iron, and that's this Minnesota Living with Heart Failure questionnaire. When we look at the COVID data, which we think is, I believe, is more representative of what's happened to the patients in the pre-specified analysis, so just focusing on the central column, we see here that the rate ratio is 0.76. So actually it's a stronger benefit. It's a 24% risk reduction. And we see the p-value is now the right side of 0.05. So it's less than 0.05 and it becomes statistically significant. And this is very similar, as I said, to the findings of another trial called AFFIRM-AHF, looking at hospitalized patients, very similar rate ratios, very similar p-values, and adds to the totality of data. Something that is important for us to have, when we're having a discussion with patients, and what we want to have is shared decision-making. It's gone are the days when it was, the carry-on films from 20 years ago, the doctors going around saying, you must do this, you must do that. You'll be reassured that isn't the case. It's shared decision-making. It's my responsibility as a clinician to discuss the options and to discuss the pros and cons of the option with patients and come to an agreed plan. And this is really helpful because the previous studies of intravenous iron didn't tell us that the average length of follow-up in this study is 2.5 years. And it's important for me to be able to look a patient in the eye and say, we didn't see any excess risk from intravenous iron. And there'd been a question mark about infection from previous studies. That definitely wasn't seen in our study. And when we look at serious adverse events, there was no excess with any organ system with intravenous iron. And in fact, there were statistically fewer from a cardiac side of things. So I think we're not seeing any worrying safety signals there. So the implications for practice, because that's what we want to change, is that this is building on other evidence, and the totality evidence, I think, tells us that correcting iron deficiency by using intravenous iron, and we can give high doses over about 30 minutes and then watch patients for another 30 minutes afterwards, can help people feel, it can help people walk further, and certainly it can now improve the prognosis, primarily reducing the risk of being hospitalized for heart failure. And we've got the reassurances about the long-term safety. What's remarkable when you do trials like this, whilst I've led the trial, there's I want to thank. So the British Heart Foundation, very, very important. Lots of other people on here that you would like to thank, or I would like to thank. It's really vital. We thank all of the patients who contributed to the trial, because each and every one of them has helped to realize these results. And I think this is something that's going to change international practice and guidelines. And as I mentioned, this was published online in the Lancet. It's what's called open access, so anyone can look this up and have a look at 400, all of the pages and figures that we've got, and the about 350 pages of supplementary analysis online. It's not good time. It's not good bedtime reading. I'll say that. I wouldn't look at that. But that's all I've really wanted to say. Thanks about the trial, Fearghal, sorry. So that's given a bit of a potted background, I hope.
Very informative indeed, Paul, and we really appreciate your contribution. And of course, if you have any questions for Professor Paul, then do please add them into the question answer box at the bottom of the screen. Can I now introduce Steve Reid and also Ruth Huntman from our Heart Stories team, where they will discuss Steve's story.
Hi,
Good afternoon. Sorry, Ruth.
Hi, Steve. Thanks very much for joining us.
Hello, everyone.
Yeah, could you just, before we talk about your participation in the Ironman trial, can you just briefly tell us a little bit about your story, because it's quite remarkable, and how you got here?
Yes. Previous to my heart attack, I've been working with the Heart Foundation as a van driver for 7 years on the Isle of Wight. on the particular day, I'd been across to the mainland and visited a few shops on the mainland to bring some stock back to the Isle of Wight. After unloading in Newport, I was off home to my home in Shanklin. I got about halfway, and just as though someone, I didn't have no pain or anything, just as though someone had chucked a bucket of water over me. The sweat just absolutely dripped off of me. But I felt fine. My little app on my watch was going a bit crazy, so I thought, I know the girls in our local chemist, so I'll pop in and see them. But I couldn't get anywhere parked near the chemist, so the only place I could get parked was in our main big co-op. And I remember driving in there, parking my van, getting out my van, locking the door. And for me, the next thing I remember was 5 hours later waking up with some bright lights and some nice music being played in Paul's Hospital in Portsmouth on the mainland. And it wasn't really until the following morning, that it sunk in that I'd had a massive heart attack. And very lucky to make it to Portsmouth.
And your heart attack, was that followed by you'd gone into cardiac arrest as well?
Yeah.
Is that right? Yeah.
Yes, yeah. And if it hadn't have been for, the knowledge of general public and the use of being able to get a defibrillator, then, I might not be here, sat here talking to you good people now. So.
And how much of a shock was that to you when it was relayed to you what had happened to you? Because you had been fine before that, had you not?
Yeah, I'd no problems whatsoever, and it did really affect me mentally, and with fatigue and that, and I just couldn't get my head around it really.
And what was your recovery like? Because I'm right in thinking that, and recalling that when you were in hospital, that's when you first found out about the Ironman trial?
Yes, that's right. Yeah. One of the lovely nurses come around and mentioned about the Ironman trial. And I kind of thought, well, I'm very much for these trials, because without, people taking part in them, I'm a firm believer in, these need to be moved on. So yeah, I thoroughly went for it, and I can honestly sit here and say that I'm really pleased I did, because the fatigue side of it was, once I had the intravenous, and but about 4 weeks after, the fatigue kind of started to clear, and I could feel myself feeling a better in myself, my attitude, my outlook on life, and it really did help me, I think.
And when we spoke before, I was quite taken aback by the psychological impact that your heart attack and cardiac arrest had on you. It took a huge toll on you. And yet you said that the Ironman trial helped you with that as well.
Yeah, it certainly did. As I say, I must have been about for a year. I mean, the mental side of things I really suffered with and really had a bad time. But taking part in the Ironman trial, I mean, I couldn't have asked for, to be looked after better. It wasn't just when you went over there, they were checking your eye, and you were being checked for everything. And, I come away thinking to myself, I know it probably feels a bit canny, but I always call Portsmouth QA Hospital my little safe haven. And whenever we were going over there for my visits and everything, it was just like someone was putting their big arms around me and saying, we're going to look after you. And that in itself, really perked me up. So, I can't thank the research team and all the doctors enough for what they've done.
And how are you now? I mean, you look really well, but how are you doing?
Yeah. Me, I had my last echo a fortnight ago, and my heart's working at 38%. I've got my ICD fitted. But yeah, I'm one of those who, you know, wake up every morning, you know, pleased to see every morning, and treasuring every day.
Cool. I still can't, even though I've heard it several times, I can't get over the kind of uncanny twist of fate that you were actually volunteering for the BHF when this happened to you, and now, but that hasn't stopped you. You know what happened to you, and the trauma and what you've been through. You're still giving back to the community, and it inspired you to raise money for defibs. Is that right? Can you tell us something about that, Steve?
Yeah, that's right. That's right. I after about a year, I think I was seeing one of my counsellors, and they said to me that, you know, there's really, you've got two choices in life: go home, put your feet on the sofa, watch daytime TV, thinking this is your life is over, or try and get back to a bit of normality. So I used to drive around the island thinking, I know how important defibs are. So I used to take photos and post them on social media, just to let people know the awareness of them, you know, and what to do. And then during the first lockdown, I looked into registering as a charity about getting defibrillated in the community. We teamed up with the Heart Foundation in their call push awareness classes, so we go around to clubs and everything, and just to try and get the awareness out there of the importance of, you know, if someone collapses, to do something rather than do nothing. And you know, I think that is one of the big issues, you know, defibs and that are out there, but it's the awareness of, you know, trying to get someone to think, hang on a minute, I might be able to do something, I might be able to help here, because at the end of the day, someone in cardiac arrest can't, you know, you can't, you know, anything you do is better than nothing.
Absolutely, I couldn't put it better myself.
Mm.
So thank you. I just want to take this opportunity to thank you for everything you have done and are doing for us. And one final question, Steve, could you just start, what would your message be to anybody who might be considering taking part in a clinical trial? Please
do, because not just for getting looked after yourself, because it helps in immense way. So, you know, people like the Heart Foundation can move on, and they can, you know, moving on, it's got to help everyone, you know, because without it, it's, you know, we're gonna be stuck. So, you know, I'd just like to thank everyone in the British Heart Foundation, all the doctors and nurses and everyone on the study, and all yourselves. Thank you from, you know, my two hearts, as I call them now. So thank you very much. Thank you, Steve. I think people will be really inspired by your story and how you've come through the other side. Thank you very much. Thank you, guys.
Yes, I was just going to say, Steve, an inspiration, and you're thanking us, but can I thank you, and also that great work that you're doing around defibrillators and CPR. Hugely important work. You can have a defib, but if you're not doing CPR in the 10 minutes between when something happens and a defib arrives, then the chances of survival are hugely decreased. So that's fantastic work. Thank you very much indeed, Steve. Stay on the line, of course, because we're going to go to question and answers now. And of course, if you've any questions, and we're getting them piling in at the moment in the Q&A section, and we'll put them to Professor Paul and Steve shortly. And also, can I introduce research nurse Serena Howe, who's involved in the Ironman trial and help patients like Steve. And Serena can help answer some of your questions. So in order of those voted in and voted up, I'll start with, is there a clinical trials register where you can put your details in case a suitable trial comes up? And that's
there is. So there is on the National Institute of Health Research, so the NIHR, there is a section called Be Part of Research. So on there, I believe you can register your interest. You can put down what your medical history is, so that they can find a potentially suitable study. Not all studies are run in the same areas, so there are some times that you have to travel if there's a study that you might be eligible for. if you get no luck from that, your local hospital will have a department that will be able to give you some information about the studies that they're running in the hospital, and they'll be able to direct you to the correct team. So for example, I work for the cardiology team. If someone was to phone up with any cardiac history and interest in research, then their details would come to me.
Excellent. And could you just call out that register again, or that link, or maybe perhaps the team can put it up in the chat if you can find it between.
It's called Be Part of Research.
Be Part of Research. Okay, thank you very much, Serena. The next question, and this is probably Paul or Serena, what steps are you taking to address those underrepresented groups in clinical trials and encourage or enable them to take part?
I mean, it's a tricky one. Ladies don't generally like taking part in research. Anecdotally, most of our participants have been male in a lot of the research studies I've done. They aren't the only underrepresented group, as you can imagine. So I know, speaking from experience in our hospital, we have a PRA group, which is a Patient Research Ambassador group. And they are a group of people who have a real keen interest in research. They are lay people, they don't work at the hospital. And they have a lot of input with research. They help the investigators write their protocols and make them a little bit more friendly for certain patient groups. They also do a lot of going out into the community and talking to people. I've written some notes. Let me just double check that I've covered everybody. Yeah. So we also have a lady who works in our hospital who does a lot of promotion for us. She works in our research and innovation department, and she goes out to community groups, certainly underrepresented groups in our community, and goes and tells them about research to try and up the engagement. It's not easy. It's very difficult to try and up the engagement, but we are certainly working on it.
Okay.
I was just going to add that I think there's an education for healthcare professionals as well, and there is sometimes a fear of asking patients to consider research that they're going to, mistrust you. It's an inappropriate fear, but I think that's been an historic problem, and I think we have to demystify this and see this as part of our clinical practice and as role, as well as discuss treatment option A that might be available already. That it's the way we advance care, and so I think it's asking patients, ensuring that we don't prejudge what a patient's going to say, and so we offer it to them. But I think sessions like this and hearing from Steve is vital to hear that. I think it's an absolute rarity to hear a patient come back, and I think what people fear is, you want to use me as a guinea pig. The majority, I think people fear that's going to be the case, but it isn't the case. So I think there are many different ways of approaching this, whether it's ethnic background. There are perhaps additional challenges there, but certainly the age and sex are things we need to be removing.
Yeah. I'm just going to jump over to a DFib question, which I might be able to answer, but I'll ask for your contributions as well, just in case there's something I miss out. And the question is there a register of DFibs which medics and first aiders can access? Well, the British Heart Foundation over the last number of years has been involved in a major project, multi-million-pound project actually, called the Circuit, where those who buy and install DFibs are encouraged to put the details of that DFib on, and also be a carer for the DFib. And those DFibs are linked to all of the ambulance services across the UK, and the final one was actually linked up just over late summer. So there's a whole network there, and if anybody collapses, the ambulance service will know immediately where the nearest DFib is, and then instruct people to go to that location to pick it up. We've also got another unique piece of software called DFib Finder, which can geographically locate it for the public, so you can see where, if you're a community group, where you'd be best advised to put it, because there might be another one near you, and you maybe put it at another location to map it. Steve, I'll just bring you in at that point. You're aware of all of this, of course, and using it.
Yes, oh yes, yeah. We got 51 registered on the circuit. Yeah, vital. It is vital that we try and get everyone mapped on this circuit. Just so people can, as soon as they ring 999, get told where the nearest defibrillator is, and especially as everyone's so overworked these days, and the time it could take to for the ambulance to arrive, it's to be able to get hold of early access of a defibrillator is vital.
Yeah, and just a wee bit of encouragement to those watching: if you're thinking of buying a defib through a community group or whatever, make sure that you consider registering it on the circuit. Or if you're in a shop or a health centre or whatever, maybe just ask those in charge, is the defib that they have behind the counter or on the wall, is it actually registered? You could help save a life at some point. So I'm going to return to the clinical trial question now. So are the majority of participants male? I think, so you touched on some of this. And how would the trials take account for women who have a very different makeup?
Yeah, so inevitably, even though you try and keep your inclusion and exclusion criteria broad to reflect the makeup of the patients you're going to see in clinical practice, inevitably there are some differences. So there is some generalizability of data, and that's whether it's trial in cardiovascular disease, in cancer, in diabetes, in respiratory medicine, that has to be the case. We do statistical analysis when there's sufficient patients in different groups. So in Ironman, for example, actually just over 25% were women. That's quite a respectable proportion. I'm not saying it's right, but it's respectable for trials that have gone before. But that gives us, effectively 300 patients who are women, and we can do some statistical analysis to make sure that there isn't an interaction difference. That is, they don't seem to get different adverse results or difference in benefits. And there's no difference certainly from Ironman, and we would look at that in age, divided according into thirds. We might look at it for people with chronic kidney disease. We might look at diabetics or non-diabetics, for example. And you're looking to see whether there's a signal of particular benefit in one group, or perhaps evidence of lack of benefit. And then you can tease that out. So those most likely to gain benefit are those that are offered the treatment.
Okay. Steve, this one's for you. Was there any drawback in taking part in a clinical trial for you?
Not at all. No drawback whatsoever. No, I can honestly say, every time we went over, from getting to the hospital, to coming away, when I had the intravenous, as I say, it's, for about 2-3 weeks, until I found the real benefits of, the iron and that. And as I said earlier on, especially for the fatigue side of things. So no, I'm really pleased, and that I was asked to take part.
It's probably just worth mentioning, I'm not sure if it was made clear. So Steve is at quite a distance from, or not in terms of miles from our hospital, but he has to come across some water to get here. So we've got the Solent between the Isle of Wight and Portsmouth, and so certainly, Steve, compared to many patients, your travel was a lot more challenging. Sort of not quite trains, planes, and automobiles, but boats.
And there's another question: what, apart from geography, then, and the sea and transport issues, what stops people? I think people are probably thinking of. But let me ask the question: what stops people taking part or being suitable for a particular trial?
So I start with that. So I think I'd come on to screen in a moment, but I think it does start with educating healthcare professionals who are delivering research to be prepared to speak to people and offer people. That's important. But I suspect that then are a multitude of concerns from, if you've got a trial to attend, the hospital, the transport, the parking, the costs, etc., that all of these things can put people off. Actually, typically we would help support people. Many trials we would have built into the costings of that to try and help patient transport, parking, taxes if necessary. Serena, I interrupted you, I think.
Yeah, that is a biggie. Lots of people find the travel really quite difficult, but like Paul said, the majority of studies, it is costed in. So if patients are coming in to see us purely for research, they shouldn't be out of pocket coming in to see us. So we factor that in with the studies. I think the biggest thing that people worry about is the concept of being a guinea pig. Now, we try and steer away from that as much as possible now, and we try and do as much education as we can with patients about it. You are not being a guinea pig, but there is still that stigma, and I think some of the previous media of things that have gone wrong with some trials doesn't help. We are moving away from that somewhat now. People don't tend to bring up some of the early studies that have hit headlines, and of those studies, they are one out of an awful lot of studies that happen. But it's always the bad things that stick in people's minds. That we do as much as we can to make it as safe as possible for people taking part. There is always, well, certainly with Ironman, there was always a doctor available. There's always trained members of staff. We have a whole team dedicated to looking after these patients.
Okay.
And I think it's important. I think it's important to reassure everybody that when we get to the stage of something like Ironman, we're using drugs that this isn't the first in man. In fact, the iron we're using is in clinical practice to treat other conditions. But it's vital that you ensure all aspects of care are optimized, and it's an holistic approach, and it isn't a brutal, let's just get through this research visit, get the information that we want, and off you go. I can see Steve nodding. It definitely isn't that. I think there's a really, trials like Ironman over 2.5 years, you really get to know people, and particularly the research nurses like Serena and Steve will form a really tight bond over that time.
Yeah. Congrats for seeing Ironman to completion, says Phoebe Kitcha. What next in terms of your research, and are you planning any new trials?
Yeah, thanks for that. So when I started this, I had a full head of hair and no grey hair. So that's what Ironman's done to me. I do consider my 4th child. It's never been that rude to me, actually. But so I actually, yeah, there'll be things. I'm involved in many other research studies, particularly in heart failure. But actually, we've got a huge amount of data still to look through. We've got the main publication out, but there's still a lot more for us to look out and publish. We've got a biobank as well to look at mechanistic samples, data from samples and mechanisms. So I think I've probably got enough from Ironman to keep me out of trouble for a bit, as well as my day job.
Yeah, and Phoebe just additionally is asking, will the people who are randomized to not receive the iron infusion be offered iron now the results are out?
Yeah, so certainly, one key thing we need to be doing is changing clinical practice and changing the way we deliver services. This isn't a drug that's got to go through regulatory approval. It's approved already. So we have a clinical service in Portsmouth because it's something we've been interested in for a long time. Certainly when we came up to the final patient visits, those in both arms of the trial, we were looking at iron indices, and we would certainly look to offer treatments to all people who've been in the trial. Yeah.
Okay. There is a question about COVID, but I think you addressed that in terms of the implications for your work. In fact, that it did slow down. So, a specific, how long does ferritin levels stay high in the body blood after infusion? Is the infusion a one-off, or does the patient require infusions at some regular intervals?
Yeah, it's a good question. So we still need to tease some of this out from the data we've got, but precisely that's, you know, there's some work. So it's interesting. This paper was published in the Lancet on the 5th of November. We just locked the study database right at the end of August, and then it's you know, you're doing the statistical analysis, you're writing the paper, getting you know, anyway, it's so that there's a lot more to dissect out. However, experience is the modern iron, and including the one that we use, ferric diisomortose, you can give a really high dose in a single infusion over 30 minutes or so. Some of the old irons, you'd have to give several infusions over several weeks to give the same amount. So there's a benefit here. And our clinical experience is that once we've done that, the iron parameters that we look for that include ferritin and liquid transferrin saturation, it's the minority of patients that need redosing early after that in the next 6, 9, 12 months. It's the minority of patients. It varies patient to patient. If you've got ongoing cause for iron deficiency, where you might be having blood leaking from your bowel, for example, that will need redosing more frequently. But the majority of people, I think it's going to be infrequent dosing.
Thanks, Paul. A thumbs up, Serena, for your work. I think here's this. Ronald Collins has said he's taken part in studies. Staff and chat, the most effective way in his view to gain trust. I think that's an encouragement. And also be given all of the facts, good and bad. Maybe, Steve, you'd like to reflect on that?
Oh yeah. As I say, you know, any problems or any questions you ask or any worries, you know, the questions are always answered from Serena and the team, like, you know. So I didn't have any concerns or worries whatsoever. You know, the treatment, well, you know, Serena knows out of this world. So you know, I can't, you know, as I say earlier on, thank Paul and the team enough. And one question I've got for Paul is, you know, next time if I need iron, try and get a bit more hair.
I'll share a bit with the both of you. Yeah. So can I just touch on, this is a specific, but somebody's asking, can they take part in a trial not having heart failure but are anemic and suffering from fatigue? There's a history of heart failure in the family. I suppose that's a criteria issue as well, isn't it?
So certainly I'm not aware of trials going on for that, but you know, iron deficiency per se outside of cardiovascular disease, it's a major world burden, and that's iron deficiency irrespective of anemia. And I think it remains poorly evaluated or under-evaluated, I should say, under-recognized, the symptoms that you can get from it. And this extends from young women with who lose blood in menstruation around the time of pregnancy, through to many other conditions. And I think it's important. Some people will respond to tablets, so oral iron. The problem we've got in people who've got kidney problems or heart failure, the conditions have something called inflammation associated with them. And this causes activation of a protein from the liver called hepcidin, and that diminishes your ability to absorb iron from your diet. And if you do absorb it, to be able to transfer it to where it's needed, i.e. all cells. So oral iron tends to be not effective in individuals with those problems. But for someone else who might have iron deficiency, oral iron may well be very effective.
Okay, and that is a question actually, just is it recommended to take iron supplements? Are you suggesting there that you do so in consultation with your doctor?
Yeah, I think you don't want to be taking them unless there's a need to take them. And certainly I think we often, so if there is a need and there's a prescription given, one of the challenges with oral iron is it can cause stomach irritation, either loose motions or constipation. Best to make it most effective, empty stomach for an hour, take it with vitamin C, so you can take it with orange juice. It's a good thing, and probably taking it alternate days makes it more palatable and more effective, in my opinion.
Okay, there's a specific condition question in as well. and it is how would this treatment affect those with hemochromatosis?
Yeah, there's a bouncer for me late in the day. So hemochromatosis, if you're not aware, is a genetic predisposition iron overload state. And so if you get things wrong and you've got too much iron, that's bad for the heart. It's Goldilocks' porridge. It's got to be just right, okay, not too much, not too little. So if you've got hemochromatosis, intravenous iron is highly unlikely to be helpful to you. And hemochromatosis, which is a relatively uncommon problem, it can cause heart muscle problems. So yes, it wouldn't be the thing to consider there.
Okay, I've got a couple more questions yet. I think some of them have been touched on, but just because there's some of them been upvoted, it might be that they haven't heard a satisfactory answer. So what criteria is usually a stumbling block to people taking part?
Or it depends on the study. Yeah, that's a hard one to say. We have each study comes with especially for the drug study, it comes with a very, very long list of what you can have and what you can't have. And generally there is no one real reason as to why someone wouldn't be eligible. It's a bit of a jigsaw puzzle sometimes trying to find people to take part, especially in more complex studies. But yeah, that's a question that it depends answer, I'm afraid.
Fearghal, do you mind if I just follow up on that and ask Serena another question? Because so Serena is, back in the latter part of 2020, the UK was hugely successful in the COVID studies with recovery, led the way in the world and helped transform, what's happened, both treatment and vaccination. And Serena, was pulled straight to the front line and onto the COVID wards and part of recovery. And I'm asking that, one, because you deserve a mighty big pat on the back for what you did then. But two, do you think the fact that so many people were being encouraged to be part of the COVID studies, and this was, almost forced research on people, do you think that will help demystify it and help ensure that we design studies that are pragmatic with not so many inclusion-exclusion criteria?
Yeah, so there were far less inclusion-exclusion criteria, and it was very much seen at that point to be a treatment option, as opposed to other studies, especially outpatient studies, where it's not necessarily seen as a treatment option. We are getting better in the NHS as using research as potential treatment options. But yes, there was far less criteria with the recovery study, and there was a lot more people engaged. We had a larger team of nurses going out and spending time with patients to try and understand whether they were willing to take part and to demystify the study. The more research staff we had to talk to people, the higher the uptake.
The other thing to say is that, if I was to design a trial and come to the British Heart Foundation asking for some the money in 2022, and I hadn't gone through extensive patient involvement in the trial design, I would appropriately be laughed away from it and say, go back and start from scratch again. And that has changed dramatically in the last 10 years to the benefit. So this is helping to design trials that are inclusive and are unlikely to put patient off by their design. And I think that the pragmatic design trials are really, really valuable here. And I think from a researcher's perspective, we've gone from thinking, what on earth could patients add to what value can they add to trial design to saying, goodness, how on earth could we ever have designed trials without patients being part of it? I think that's a really important message. And please, feel free to, discuss with colleagues, put yourself forward if you're interested in that.
Lovely, lovely way to conclude, Paul and Serena. Paul and Steve, thank you all very much indeed. And thank you for watching this edition of Live and Ticking. We hope you've enjoyed hearing from our brilliant speakers. Before we wrap up, the poll question: how would you understand your knowledge of clinical trials? 1, very little, or 2, or 5, sorry, a lot. If you just put into the voting page there. If we haven't managed to answer your question today, then we encourage you to visit our Heart Helpline, where you can contact our dedicated clinical team about your query. Just a wee reminder about the Heart Hero Awards. Please join us for the BHF Heart Hero Awards 2022. The 5th annual awards will take place tomorrow, 1st of December at 8 o'clock, and then you can join the celebration online through our live stream. Host Vernon Kay will guide you through each category and this year's Inspirational Heart Hero nominees. I'll be there, by the way. We'll also have guest celebrities announcing some of our winners. Register to watch the celebration online. Our next Live and Ticking event will be recorded and available on YouTube channel from next week. Thank you again for joining us, and goodbye.